Hi guys, welcome to my channel. In this video, let me explain input buffering, specification of tokens, token recognition, and introduction to Lex programming. Before going in detail, let me give the brief idea. These topics are part of lexical analysis, the phases of compiler design. In this presentation, we will understand how lexical analyzer reads the source program efficiently using the input buffering and how it identifies the token and how the Lex tool automatically generates a lexical analyzer. We'll go into the slides and we'll see in detail. The agenda of today's presentation: lexical analysis introduction, input buffering, double buffering and sentinel technique, token rectification, regular expression, token recognition, Lex introduction, Lex program structure, sample Lex program, advantages, and finally we'll end up with a summary. Let's go into the slides and let's see in detail. Input buffering. What is input buffering? Input buffering is a technique used by the lexical analyzer to read source code efficiently by storing the characters in memory before processing them. Now let's understand input buffering. When a compiler reads a source program, it has to process thousands of characters or even millions of character. If the compiler reads every character directly from the source file, the process become very slow because each read operation requires accessing of the disk. The disk access is much slower than memory access. To solve this problem, the compiler uses the input buffering. In input buffering, instead of reading one character at a time, the compiler reads block of character from the source file and then store them in memory. The lexical analyzer reads the character from the memory buffer. Since the memory is much faster than disk, the compiler works much more efficiently. This is the diagram you can see. So source program input buffer and then it will give to the lexical analyzer. Some of the advantages: faster input reading. The compiler reads many characters together instead of one by one. Reduces disk access. Since fewer disk accesses are required, the program executes faster. Improves the compiler performance. The lexical analyzer speeds less time waiting for input. Efficient for large program. It works very well even for the large source file. I hope you guys understood. Let's move on to the next slide. Double buffering. To further improve the efficiency, the compiler uses this technique called double buffering. The double buffering techniques has mainly two parts, buffer 1 and buffer 2, which has a two equal sized buffer. The working: when the first buffer becomes empty, the compiler immediately switches to the second buffer. While the second buffer is being processed, the first buffer is filled again. This process continues until the entire source program is read. This ensures the continuous scanning without any interruption. You can see the buffers, first buffer and buffer 2. It has some advantages: faster scanning, no repeated disk access, better compiler efficiency. We'll move to the next slide. Specification of tokens. What is tokens? It is nothing but which is the smallest meaningful unit of the program recognized by the lexical analyzer. You can see the general format: token name, comma, attribute value. The token name always tells us the category of the token. The attribute value stores the additional information such as actual identifier name or value of the constant. We can see the table right hand side, lexemes and tokens. If keyword, while is a keyword, total is an identifier, 250 is a number, plus is an operator, and semicolon is delimiter. And we can see on the left hand side the categories of the token: keyword, identifier, constants, operator, and delimiter. I hope you guys understood. We'll move on to the next slide. Token specification using the regular expression, which describes the pattern for token. You can see the example table there. Identifier, letter, integer, digits, float, dot operator plus digit will be followed by the digit. Keyword, if, while, for, operator, plus, minus, star, and division. Why regular expression is important? For easy to specify the pattern and automatic token generation, and which was used by the Lex programming. We'll move to the next slide. Token recognition. What is token recognition? A token recognition is a process of identifying the token types of each lexeme. So it's nothing but it's a process where the lexical analyzer scans the source program and identifies which token each lexeme belongs to. Let's understand in detail with the steps. Lexical analyzer reads the character from the input buffer. That is the first step. Then it compares this character with predefined regular expression patterns. Then it will go to the third step. Once a pattern matches, it determines the token type. And finally, it sends that token to the syntax analyzer. Example is input. In sum equals a plus 25. Output is identifier is sum. Assignment operator is equals. Identifier is a, plus is plus operator. Number is 25. Semicolon is semicolon. This is how it works. Character, again pattern matching. Again it recognizes the tokens. I hope you guys understood. We'll move on to the next slide. Introduction to Lex Programming. Writing a lexical analyzer manually can be difficult and it is a time consuming. To simplify these tasks, we use the tool called Lex. What is Lex? Lex is a software tool that automatically generates the lexical analyzer from the rules written using the regular expression. Instead of writing the hundreds of lines of C code to recognize the token, we simply write the patterns in the Lex file. Lex reads this pattern and automatically generates the scanner program. The uses, the token recognition, pattern matching, compiler construction, text processing. The advantages are like automatic scanner generation, faster development, less coding, easy maintenance. I hope you guys understood. Let's move on to the next slide. The structure of Lex program. A Lex program contains these three sessions mainly: definitions, rules, and user subroutines. A definition session, which involves header files, variable declaration, macro definitions, or regular expression definitions. Second session is rules. This is the most important session. Each rule contains a pattern or an action. Whenever the input matches a pattern, the corresponding action is executed. The subroutines contains the helper function written in the C. It usually means wrap, additional user defined function. We'll go to the next slide and we'll see the sample Lex program. For example, ash include stdio.h is a definition. And coming to the action phase, printing, number, printf, identifier, printf plus operator. Then it is said to be the rules. And last is like user subroutines. Int wrap output is this. Summary. The input buffering improves the compiler efficiency. Double buffering speeds up the file reading. Tokens are specified using the regular expression. Lexical analyzer recognizes the tokens. Lex automatically generates the lexical analyzers. Lex program contains the definition, rules, and user subroutines or user code. I hope you guys understood. Thank you. If you get any doubts, please raise your doubts in the comment box so that I can respond. Thank you, one and all.